Bismillah, alhamdulillah, salatu wassalamu ala rasulillah. Today's class is about 6.5 recitation exercises. We will practice by solving the recitation exercises of section 6.5. Let's summarize or remember the summary of this section. In here you have the definition of the inverse trigonometric function. Sine inverse of x is y, if and only if sine y is x. And of course, these expressions are not valid unless we are working within the domain of these functions and the range of these functions. The domain of sine, cosine inverse is the closed interval -1 and 1. The range is -π/2 and π/2 for sine inverse and 0 and π for cosine inverse. To remember that, you need to go to the first definition of these functions. When we define sine inverse, if you remember, it wasn't 1-to-1. So we take this as a restricted domain for sine. Then it becomes 1-to-1. Then we have inverse function, and this inverse function has this as a range, and this one has this closed interval as a domain. The same can be said about cosine inverse. For tan inverse, the domain all the real numbers, and the same for cotan. For the range is the open interval -π/2 and π/2, as it is not defined. We had horizontal asymptotes at these 2 points. Now the inverse function property or the cancellation property, when you have f inverse of f of x, you know that this is x, but not for any x. This is for x in the range of the inverse. If you have f of f inverse of x, this is equals to x, but not for any x. It is for x in the domain of the inverse. So here, x is in the range of the inverse. Here it is in the domain of the inverse. You can apply this wherever your function is, sine or cosine or tangent. As you know, that if you have sine inverse and what you have inside is positive, then the result or the output of sine inverse will be in the first quadrant. It will be angle. You know that sine inverse or cosine inverse at the end, it is an angle. If the argument is negative, you have sine in the fourth quadrant with negative direction. This is the positive direction. This is the negative direction. The same for tan inverse. For cosine inverse, it is in the second if the argument is negative. For cotan, cosecant, and secant, the same. Be careful. You cannot use the cancellation property or the inverse function property unless your x is within these intervals. Let's apply these properties on these exercises. And of course, we can revert to this whenever we need. Find the exact value of each expression. Cosine inverse -√3/2. Now, in such question, you need to ask yourself 2 questions. The first question, you don't know what is cosine inverse -√3/2. So let's say that it is x, for example. Now you will ask yourself 2 questions. What is the angle? This means that cosine x is -√3/2. So it is an angle. In fact, let's call it theta. It's better to call it theta. So cosine inverse -√3/2 equals to theta or x or whatever. Now cosine theta equals to what? So the question is, what is theta? What is this theta? What is the angle that its cosine is -√3/2? Some of you, they may say it is in the second quadrant, 5π/6. Good. Another one, he may say 5 or 7π/6. It is also cosine of 7π/6 is -√3. But this one will be accepted. This will not be accepted. Why? Because cosine inverse, whatever you have inside, whatever you have here, cosine inverse will be always between 0 and pi, greater than or equals 0, less than or equals pi. So this is the range. We call this the range of cosine inverse. So now this theta will be 5π/6. This one is not between 0 and pi. This one is between 0 and pi. It is in the second quadrant. If you remember what I told you here, if what is inside cosine inverse is negative, then your angle, the result of cosine inverse, will be in the second quadrant. So let me say let me repeat that again. So now cosine inverse of negative square root of 3, whatever you will have here, it should be between 0 and pi. It should be inside this interval. Not only that, you should have also cosine theta equals to negative square root of 3 over 2. So you need to check two things. Is cosine what you have is negative square root of 3 over 2? And is this angle between 0 and pi? So now if you think about these two things, you will find easily that theta is 5 pi over 6. Check. Cosine 5 pi over 6 is negative square root of 2. 5 pi over 6, it is between 0 and pi. 5 pi over 6 is greater than 0, less than or equals 1. So it is checked. So what we conclude from this at the end, that cosine negative square root of 3 will be equals to 5 pi over 6. How to check? It is inside this interval, and its cosine is negative square root of 3 over 2. Okay, let's solve the next one with the same concept. Sine inverse square root of 2 over 2. You don't know what is it, call it theta for an instant. Now you need to have this theta between what and what? This is sine inverse. Sine inverse, its output, sine inverse is between 1 and negative 1. By the way, we forgot to check the domain. For the domain, if it is defined or not, this one, the input should be between negative 1 and 1. So here it is negative square root of 3 over 2. It is less than, it is in fact between negative 1 and 1. It is greater than negative 1, less than 0. So it is defined. Here, sine inverse square root of 2 over 2 is the square root of 2 over 2 is less than 1, between 0 and 1, between negative 1 and 1. Yes, square root of 2 over 2 is between 1 and negative 1. So no problem. It is defined. Now what we need to do to think about an angle that its sine is square root of 2 over 2. Not only that, and it is in, by the way, let me repeat that. This is the range of cosine inverse, which should be in the range of sine inverse. What is the range of sine inverse? Square root, it is a closed interval, negative pi over 2 and pi over 2. Now you need to check two things. The sine of theta is square root of 2 over 2, and this theta is between negative pi over 2 and pi over 2. So one of you, they may say pi over 4. Ask yourself, is sine pi over 4 is square root of 2 over 2? Yes. Is pi over 4 between negative pi over 2 and pi over 2? Yes. So it is done. So this theta, in fact, it is pi over 4. And sine pi over 4 is square root of 2 over 2. You are right. Why it is not 3 pi over 4? Look, sine 3 pi over 4 is square root of 2 over 2. In the second quadrant, positive. But this one, 3 pi over 4, it cannot be output. It cannot be output for the inverse. So if you say that sine inverse square root of 2 over 2 tsawi 3 over 4, this is wrong. This is not true. Why? Because 3 pi over 4 cannot be output for sine inverse. It cannot be a value for sine inverse, because all the values of sine inverse are what? Are between negative pi over 2 and pi over 2. 3 pi over 4 is greater than pi over 2. It is in the second quadrant. And this should remind you about what I said here. Wherever you have the argument inside them is positive, so the result is an angle in the first quadrant. If what is inside sine inverse is negative, it will be in the fourth. Now I think you can solve the last one. Now tan inverse negative 1. Do you remember that what we said during the class? I think it is mentioned here. Here it is. Only sine inverse and tan inverse are odd. All the other functions are neither even nor odd. So we have only sine inverse and tan inverse that they are odd. So we should take benefit from this. If you want, by the way, you can solve it even without this property. Tan inverse of negative 1, indeed, it is negative tan inverse 1. Now what you need to ask yourself, which angle that its tan is 1? What is the angle? Think about tan inverse of 1, it will be theta. Now you need to think that by the definition of the inverse, this means that tan theta is 1. So you need to ask yourself, what is theta? What is the angle that its theta is, that its tangent is 1? And of course, it is between negative pi over 2 and pi over 2. It should be an output because theta is tan inverse. Tan inverse is less than pi over 2, greater than negative pi over 2. For whatever the argument inside, tan inverse is always between negative pi over 2 and pi over 2. Okay, whatever you have here. What is this theta? This theta is pi over 4. Why not 7 pi over 4? Sorry, 5 pi over 4. 5 pi over 4 also, 5 pi over 4, its tan is 1, but it is not between negative pi over 2 and pi over 2. Okay, so this will be equals to what? Negative tan inverse of 1 is what? Pi over 4. So it will be negative pi over 4. And this should remind you also about what I said. When you have the argument inside tan inverse is negative, then where you are? Here. When you have what is inside tan inverse is negative argument, then the angle is in the negative direction, in the fourth quadrant, in the negative direction, not the positive direction. Another way to solve this is directly. You need to call this theta and you need to ask yourself, what is the angle that its inverse is negative 1, that its tangent is negative 1? So this means tan theta equals to negative 1. What is theta? What is the angle that its theta is negative 1? You may say 3 pi over 4. 3 pi over 4. This angle, its tangent is negative 1. But this one is in the second quadrant. It is not in this interval. It is not between negative pi over 2 and pi over 2. What is this? This is the tan inverse range, the range of tan inverse. It is not in the range of tan inverse. It cannot be output for tan inverse. It cannot be a value for tan inverse. So in fact, the angle is negative pi over 4. Theta is negative pi over 4. You cannot find any another angle that its tangent is negative 1 and it has an inverse. This is coming, guys, from the restriction that we made on the tan inverse. You remember? Tan inverse is not 1-to-1. We take the restricted domain to be for tangent between negative pi over 2 and pi over 2. So after that, it becomes 1-to-1 and we had an inverse. So out of this interval, we don't have an inverse function for tangent. And you know that the domain of the function now is the range of the inverse. Okay, let's go to the next exercise. Now, this exercise is about using a combination of trigonometric inverse function and also trigonometric function. They might be the same function like here, cosine inverse cosine, or like here, sine inverse cosine, different ones. So when you have something like this, it is easy. You need to remember the inverse function property or the cancellation property, which they are mentioned here. Cosine inverse of cosine x is x, only if x between 0 and pi. These are the warnings. Of course, the general cases are here. When you have sine inverse, here sine inverse sine, and the same for the others. Be careful. Is it sine of the sine inverse or sine inverse of x, of sine? It is not difficult. Just here, this will be output in the this will be in the domain of the sine inverse. This will be in the range of cosine inverse, sine inverse. Focus on the inverse. It will be easier. Now, cosine inverse cosine, again, cosine inverse cosine x is x. So it is x. What is x? 3 pi over 5. What you need to check is this 3 pi over 5. Is this x between 0 and pi? 3 pi over 5. 3 pi over 5. Greater than or equal 0. Good. Is it less than pi? Yes. 3 over 5 is less than 1. So 3 pi over 5, it is less than pi. So it is true. This is direct. How to justify your answer? This is in the interval 0 and pi, which is what? Which is the range of cosine inverse. Again, as I said, this will be an output for cosine inverse. So we have cosine inverse whatever. It should be at the end between pi and 0. Ask yourself, is the result between 0 and pi? Then you are right. Excellent. Check always that the answer is that you can apply. If, of course, if it is not, we will see here, for example, in the next examples, what we can do about it. Like here. Here we cannot apply these formulas because these are for inverses. When you have a composition of the function and its inverse. Here, it is not a composition of the function and its inverse. It is a composition of sine inverse and cosine. To do this, what you need to do, you need to evaluate what is inside. This is cosine, usual cosine. You know how to evaluate sine. So this is cosine 5 pi over 5. What is this? Remember, this question is from chapter 5. How to evaluate cosine 5 pi over 4. You need to ask yourself in which quadrant is this, and what is the reference angle, and what is the value. At the end, we need the value of this. So now cosine 5 pi over 4, 5 pi over 4 is in the third, so it is negative. Cosine is negative there. And how to find the reference angle in the third? We will subtract pi from the angle. This will be equals to sine inverse negative cosine what? 5 pi, it will be cosine pi over 4. What is good that we can take this negative out because sine inverse is odd, but let's keep it to the next step. It will be negative. What is cosine pi over 4? Square root of 2 over 2. Now you have two options. One option is to take the negative out because sine inverse is odd. This is one way. And then you will ask yourself sine inverse square root of 2. What is the angle that its sine inverse is square root of 2 over 2? And it is between negative pi over 2 and pi over 2. It is pi over 4. So this is the answer. Then the other way is to ask yourself directly from here. What is the angle that its sine inverse is negative pi over 2? That its inverse, what is the angle that its sine is negative square root of 2 over 2? And you find that this angle is negative pi over 2, pi over 4. Negative pi over 4. It should be always remember that sine inverse is between pi over 2 and negative pi over 2. So if the argument is positive, it is between 0 and pi over 2. If it is negative, it is between negative pi over 2 and 0. Excellent. Now let's find the third one, tan inverse. We have here tan inverse, tan 4 pi over 3. Again, they are inverses of each other. So the same function with the inverse. So we can apply this, but you should be careful. You should ask yourself, tan inverse of tan of x is x only if x between negative pi over 2 and pi over 2. Is this between negative pi over 2 and pi over 2? No. 4 pi over 3 is greater than pi over 2. Of course, it is greater than negative pi over 2. So it is not. So what should we do in this case? You have two options. Option number one, to simplify this such that the argument will be inside that interval. So one way is to, first of all, let me mention why it is not. This is not 4 pi over 3. Why? This is not. Because this number is not in the range. It is not in between negative pi over 2 and pi over 2. It is not in the range of tan inverse. It cannot be output for tan inverse. So what is it? If it is not 4 pi over 4, what is it? We will evaluate this. One way is to evaluate what is inside. How to do that? It will be tan inverse 4 pi over 3. It is just use your ideas from chapter 5. Tan 4 pi over 3. This is in the third quadrant. So it will be what? Positive. It is in the third. So it will be tan. And to find the reference angle in the third, you will subtract pi from the angle. So this will be tan inverse tangent of pi over 3. Now you can use the cancellation property. This will be equals to pi over 3. Check, is this between negative pi over 2 and pi over 2? Yes. So it is done. Another way is to evaluate. What is tan pi over 3? Tan pi over 3 is, it will be tan inverse of square root of 3 over 2. Over 3 over 1. Square root of 3. Tan inverse square root of 3. What is the angle that its tan inverse is square root of 3? It is pi over 3. But no need for that. I believe that the first option is better, to use the cancellation property. Okay. Next, sine inverse sine 3 pi over 5. Now again, we have here a composition of the function and itself, and we expect to have cancellation. So do we have a cancellation here? So is it equals to 3 pi over 5? This is a question. The answer is no, it is not. Why? Because this output is not between negative pi over 2 and pi over 2. What is this negative pi over 2 and pi over 2 closed interval? This is the range of sine inverse. So this is not in the range of sine inverse. So it cannot be. It cannot be. So what is it? You know 3 pi over 5 is greater than pi over 2. So how to do that? What we will do, we will try to simplify or evaluate what is inside if we can. Of course, this is not well-known angle. We cannot evaluate it. We need to determine the quadrant. 3 pi over 5, it is for sure less than pi and greater than pi over 2. So it is in the second. Since we are in the second, do you remember how to find the reference angle in the second? We will subtract the angle from pi. And in this case, we will have sine inverse sine 5 pi minus 3 pi, 2 pi over 5. And this, of course, now equals to 2 pi over 5. Now we can cancel. Why we can cancel now? Because the result now is between negative pi over 2 and pi over 2. You know that 2 pi over 5 is less than pi over 2. 2 over 5 is less than a half. So this is now in the first quadrant. And it is, of course, positive. So we can now apply this inverse or cancellation property. Okay, so this is the answer. The last one is so easy, guys. Here we have the composition, but not of this type. We don't have here cosine inverse cosine. We have cosine inverse. Let's go back to check what is the rule in that case. Cosine inverse x is x if x between negative 1 and 1. This x now should be where? Should be in the domain. This should exist first. If this exists, we will think about this. But if it does not exist, what we have to do? This should be exist. So now it should be in the domain of cosine inverse. What is the domain of cosine inverse? Negative 1 and 1 closed interval. The closed interval. Now, is this pi over 2? Pi over 2. Is it in the domain of cosine inverse? You know, pi over 2 is approximately 1.5, 7, something like this. So it is not. This is greater than. So what we will say here? We will say that this is undefined. Why it is undefined? Pi over 2 does not belongs to negative 1 and 1. What is this negative 1 and 1? The domain of cosine inverse. Why it is not there? Pi over 2 is greater than 1. It is not in that interval. We cannot evaluate. There is no angle its cosine is pi over 2. Okay. Excellent. The third question is about the range. Do you remember what is the range of cosine inverse, or I should remind you about it? Here it is. The range of cosine inverse is this, square root 0 and pi, the closed interval 0 and pi. Now, we don't have here only cosine inverse. We have cosine inverse of 2 minus 7x multiplied by negative 1 and added to k. He said that if the range of this function, it is this closed interval, then what is k? One way to solve this question is what? To start to build up your function. So you will start with cosine inverse whatever. Here we have, of course, horizontal transformations. So whatever the argument of cosine inverse is, of course, defined, it should be cosine inverse is always between 0 and pi. From where we bring this one? From the domain, from the range. Let me remind you here. The range of cosine inverse, whatever cosine inverse inside it is the closed interval 0 and pi. So this is why we have this. Okay. Now what we will do, we will build our y. The question is about the range, so it is about y. Where is y? cosine inverse between 0 and pi, so negative cosine inverse will be where? We will multiply both sides by what? By negative. So this will be what? Less than or equal, in fact, it is greater than or equals negative pi, less than or equal 0, which I prefer to write it this way. Less than or equal 0, greater than or equals negative pi, which is the same. It is the same. So just I reverse. I will bring this one that on the right and that one on the left. What is remaining? We need to add k. So we will add k for both sides. So when we add k here, this will be what? 0 plus k, it will be k. And here it will be negative pi plus k. I added k for both sides. Now, what is this here in the middle? This is our y. Now, this is the range. The range is about, where is y? Y between 0 and what? So from here, the range is the closed interval negative pi plus k and k. Now compare this with this, with what you have here, with what is given for you. So according to that, what you can conclude is that this is equals to pi and 2 pi. Clearly, k is 2 pi and negative pi over k is pi. Whether you use this one or that one, in both cases, k is 2 pi. Whether you use the first endpoint or the last endpoint of the interval, the left or the right endpoints. Clear? Okay, when you have the domain, it is natural to build your function and obtain the range of the function. The answer is 2 pi. The last question in the recitation is about the domain of sine inverse. And you should remind yourself here, what is the domain of sine inverse? Whatever is what? The closed interval negative 1 and 1. You remember that? So now for this expression to be exist, we should have the argument here. What is inside? You know, the domain is about x, not about y. So this expression is defined if the argument inside sine inverse, which is here x over 3, this should be between negative 1 and 1. So if it is between negative 1 and 1, we can evaluate it. Otherwise, it is not defined. So now we will, the question is, what is x? So it is about what is x. We will solve it for x, multiply both sides by 3. Now x should be between negative 3 and 3. This means that the domain of this function that we are working on is the closed interval negative 3 and 3, and the answer is C. So easy question. So it is about the domain, not the range. Be careful. If the question here is about the range, it is good to make a combination between them. If we are working on the range, what you will do? To work on the range here, you will say that sine inverse, whatever, it will be between pi over 2 and negative pi over 2. And if you multiply by 2, you will build your function, build up your function. You multiply by 2, this will be pi and negative pi. And this is why between pi and negative pi. And of course, according to that, the range of this function will be the closed interval negative pi and pi. I wish that this clarifies the difference between calculating the domain and the range for such functions, because this is so common in the old exam questions. As you can see, these are some solved exercises for you. I have also solved several old exams for you to practice and check your answer. This is about the domain, so he will work on the argument. When the question is about, this is the exact value. This is also about evaluating such functions. Again, when this is about the range, he will of course build the function. He will start from cosine inverse, then multiply by negative, then add negative pi over pi, and see where it is. This is all what we have for today. Thank you, and see you inshallah next time.